Welcome to The Explainer. I am absolutely thrilled to have you here today because we're looking at a deeply fascinating paper that is quite honestly going to completely change how you view global trade. We tend to think of the global economy as this vast, decentralized, almost invisible cloud, right? But physically, when you actually look at the geography, it all comes down to a few very narrow, highly vulnerable stretches of water. Today, we are breaking down a groundbreaking 2024 paper by Vipin P. Vettel and Fathimath S. Vimarath. And what they've done is build a model to figure out exactly what happens to the world economy when these vital maritime choke points just completely shut down. Okay, let's dive right into this because the real-world stakes here are incredibly visceral. You all remember March 2021, right? The Ever Given. A single, massive container ship somehow wedges itself totally sideways in the Suez Canal. And just like that, in a literal instant, roughly 10% of all world seaborne trade is completely gridlocked. It was a massive wake-up call for the entire planet. But as we're going to see today, it turns out that the way most experts actually try to calculate the economic damage of events like this, and the even bigger crises we've seen since, is just fundamentally flawed. So, here is our roadmap for today's explainer. We're going to cover the narrow seas, the myth of the lost cargo, the heavy tail risk, why exporters suffer the most, the domino effect, and finally, we'll look at the proof in the Red Sea. Starting off with Section 1, the narrow seas, looking at the physical geography of global trade. A quarter of a millennium ago, Adam Smith, the father of modern economics, noted that the division of labor is limited by the extent of the market. And what extends that market? Water carriage. Today, that observation is entirely planetary. Our modern supply chains stretch across multiple continents, carrying crude oil, chemical feedstocks, and essential raw components. But this immense planetary division of labor is literally forced to squeeze through maritime passages that are, in some cases, just a few miles wide. Looking at the 12 maritime choke points mapped out here, you'll immediately notice two distinct shapes. The circles represent what the authors call bypassable gates. Think of the Panama Canal, the Suez, or the Strait of Malacca. If one of these closes, ships can technically take a detour. It costs a lot of time and a whole lot of money. You can literally see those dashed lines showing the incredibly long routes around the Cape of Good Hope or Cape Horn. But eventually, the goods do arrive. But then, look at the red squares. These are terminal gates. We're talking about the Strait of Hormuz, the Danish Straits, the Turkish Straits. These are the sole sea exits of enclosed basins. There is absolutely no viable detour. If a terminal gate closes, the cargo trapped inside simply cannot reach the open ocean. And this distinction between terminal and bypassable is going to dictate absolutely everything about who survives and who suffers when trade breaks down. Which brings us to Section 2, the myth of the lost cargo. We really need to shift our paradigm here. So, the old myth basically says that if a strait closes, the economic cost is just the value of the cargo that normally crosses it. If $1 billion worth of goods goes through and it closes, well, you lose $1 billion. Simple, right? But that is fundamentally wrong. In our modern production network reality, a severed shipment isn't just a box of stuff lost at sea. It's a missing input. It's the oil that shuts down a refinery in Korea, which then halts a chemical plant in Germany, which then stops car production in the US. The loss cascades downstream through the entire global factory network. The true cost isn't just that pre-shock cargo value, because the global economy is this incredibly complex, living, breathing network. It constantly engages in what the authors call equilibrium rematching just to survive. If a route gets cut, buyers don't just sit there, they frantically scramble to find alternative suppliers, and trapped sellers try to push their idle goods to whatever customers they can still physically reach. You cannot calculate the real damage just by looking at the ships that used to sail. You actually have to calculate how the entire world network rewires itself in real time. Moving on to Section 3, the heavy tail risk. Let's talk about this unequal global fallout. Now, what's really interesting about these 12 single choke point closure maps is the massive inequality that emerges. Check out the top left, the Strait of Hormuz. See that deep, dark red concentrated entirely in the Middle East? That represents extreme, devastating economic contraction for a few specific countries, while the rest of the world remains that relatively pale yellow color. You can see the exact same pattern for the Danish Straits on the top row, third from the left, deep red around the Baltic Rim, places like Poland, but relatively minimal impact globally. Terminal gates create this deep, highly localized damage, utterly decimating the economies trapped directly behind them. Meanwhile, bypassable gates like the Suez or Panama on the right side create broader but much shallower, pale yellow ripples across the rest of the globe.
To really put a number on that deep red concentration, the United Arab Emirates would lose roughly 17% of its entire GDP from a closure of the Strait of Hormuz alone. Think about that for a second. A devastating double-digit contraction, wiping out nearly a fifth of their economy, just from one single waterway shutting down.
But honestly, the most fascinating part of this heavy tail risk is what the authors identify as hidden vulnerabilities. A country doesn't even need to sail its own ships through strait to be hurt by it. For example, the model shows Japan losing about 0.5% of its entire GDP if Hormuz closes. And here's the kicker. Not a single Japanese hull actually has to cross that strait for this to happen. Japan's economy simply relies on the specific grades of Gulf crude that suddenly become completely unavailable to the global market. It proves that this vulnerability is literally baked into the production network itself. Section 4, exporters suffer the most. This is the great asymmetry. When we break it down by choke point, the dark blue bars representing the severed exporters are drastically longer than the light blue bars representing the demand side. Look specifically at the very top row for Hormuz. The supply side loss is a staggering 17.1 times greater than the demand side loss. It's not even close. Even when you look at the Turkish Straits or the Kerch Strait, the pain is overwhelmingly, disproportionately borne by the exporters.
So why does this happen? Well, it all comes down to economic geography. Sellers, especially of commodities like oil, grain, or rare ores, are often physically trapped behind a single terminal gate. If Hormuz closes, Gulf exporters simply cannot get their oil to the ocean. Period. They are entirely cut off. Buyers, on the other hand, are diversified. If a massive refinery in India can't get Gulf crude, they will just pay a premium to source it from the Americas, West Africa, or the North Sea. Buyers can resource. Trapped exporters simply cannot.
When you decompose this economic loss, it reveals exactly why this dynamic plays out. Look at the top two bars, Saudi Arabia and the UAE. Those massive dark blue chunks represent direct severance. They lose value simply because their physical links to the outside world are literally cut. Now look further down at importers like China or India. They have almost no dark blue at all. Their losses come purely from the light blue network propagation and the brown bundle penalty, meaning they only lose money because the alternative inputs they are forced to buy are more expensive and less efficient for their factories. It's a completely different mechanism. The two sides of the strait suffer for structurally different reasons.
Let's look at Section 5, the domino effect, joint closures and additivity.
Modeling 3 highly realistic, albeit terrifying, geopolitical scenarios reveals how rapidly this contagion spreads. The top map shows a Middle East escalation, closing Hormuz, Bab-el-Mandeb, and the Suez Canal all simultaneously. You can see the massive expansion of that deep red damage zone immediately engulfing the entire Middle East and East Africa. The middle map models an East Asia closure, Malacca, Taiwan, Luzon, and Korea. Here, the pain spreads widely and sharply across global tech and heavy manufacturing hubs. And the bottom map shows a Russia-Europe closure, the Turkish, Danish, and Kerch Straits. That deep red totally consumes Eastern Europe and the Baltic Rim, completely devastating countries relying on those very specific food and energy corridors. But the absolute most crucial point here is how these closures interact mathematically. They are not just simple addition. Some are what we call subadditive. For example, the Suez Canal and Bab-el-Mandeb are essentially on the exact same route. If you close one, the route is cut. Closing the second one in series is redundant. It doesn't double the economic damage. But other closures are super additive. If you close parallel routes that supply different essential inputs to the exact same global buyers, the economic damage compounds exponentially. It completely starves common buyers and triggers massive downstream cascading failures. Finally, Section 6, proof in the Red Sea. Let's validate this theory with some actual real-world data. And this brilliantly illustrates the real-world impact. When we plot the value-added growth of countries based on their Red Sea network exposure, a striking reality emerges. See that dashed vertical line? That's December 2023, the onset of the recent Red Sea crisis. Before the closure, to the left of the line, the trend is flat. There's practically zero correlation. But look at what happens after the onset. The profile dips sharply into the negative, hitting a distinct, statistically significant trough about 3/4 or almost a full year into the crisis. The model's predicted footprint perfectly matches the real-world economic decline we actually experienced. And just to ensure this was specifically due to the Red Sea and not just general global sluggishness, the authors ran a horse race regression against orthogonal gates, placebos like the Panama Canal and the Korea Strait. As you can see, the red line for the Red Sea stays robustly negative and statistically significant. Meanwhile, the blue lines for the Panama and Korea footprints completely collapse to zero.
The global economic decline loaded specifically and exclusively onto the Red Sea's unique predicted footprint. Testing this exact mechanism across 4 completely different historical episodes reveals something huge. The Ever Given blockage in 2021, that third line down, was a massive shock, yes, but it was resolved in just 6 days, making it far too transient to cause a measurable macroeconomic shift. The Panama drought on the bottom line was too gradual. Only the sudden, sustained Red Sea closure at the very top perfectly matches the predicted negative macroeconomic sign. Sustained closures are what actually trigger the true production network damage. Now, for the technical learners out there, this builds a rock-solid mathematical foundation. The heat maps on the left show the Red Sea loss surface across different friction and substitution variables, proving that their baseline sits in a highly conservative, consistent band. And the charts on the right prove the model's numerical stability, showing pristine, monotone exponential decay. So the math behind these terrifying scenarios is incredibly sound.
All of which leaves us with a pretty profound realization. Global trade risk isn't just about counting the ships that pass through a strait. It's about tracing the irreplaceable inputs that your country's factories rely on every single day. So I'm going to leave you with this question. If a distant, irreplaceable maritime gate closed tomorrow, what hidden vulnerabilities in global supply chains would devastate your own country's economy? Thank you so much for joining me for this deep dive on the Explainer. Keep questioning the map and keep learning.